Jai Hind everybody. My name is Dr. Nandita Goyal. I am working as an assistant professor in Department of Information Technology at AKGEC, Ghaziabad. So today I'll be discussing the topic rules of inference, which is basically a topic from discrete structures, and this is one of the important topics of discrete structures, that what are rules of inference and how do we apply these rules of inference to check the validity of different arguments. The topics that I will be covering in my lecture today include inference theory, then what is the structure of an argument, what do we mean by validity of an argument, what are the different rules of inference which can be applied to check the validity of an argument, and then we will be discussing a few examples. Now, if we talk about inference theory in discrete mathematics, it can be described as the analysis of the validity of the formula from the given set of premises. I have a given set of premises and I want to check that whether a given argument is valid or not, then I can check that by applying the inference theory. So, in order to deduce the new statements from the given statements whose truth value is already known to us, we can actually apply the rules of inference and find out that whether a given argument is a valid argument or not. Now, what do we mean by these rules of inference? So, whenever the topic rules of inference comes into picture, the one and the most important topic which needs to be known to us is mathematical logic. Mathematical logic is actually often used to check the logical proofs. The proofs are valid arguments that determine the truth values of different mathematical statements. So, in order to determine the mathematical values or the truth values for these statements, we need to apply rules of inference. Whenever we talk about rules of inference, then we have one of the most important terms which is known as argument. Now, what an argument is? Actually, an argument is nothing but a well-defined sequence of statements. And when I talk about these sequence of statements, I can divide these statements into two categories. One is premises and the last statement is known as the conclusion. So, an argument is nothing but a sequence of statements in which we can divide the entire sequence of statements into premises, and we can say that the last statement is known as the conclusion. The conclusion is used to indicate the last statement and the premises are used to indicate all the remaining statements. And usually we make use of the symbol therefore. This is a therefore symbol which is usually placed before the conclusion. So, if I see the syntax for writing the premises and conclusion, this first line shows my premises, that is P1, P2, P3, P4 up to Pn. All these are premises which will form an argument, and the last statement, suppose we have this Q, this is known as the conclusion. So, whenever we'll write these something like this. I have P1, P2 up to Pn. These are my premises and therefore Q. This is the way in which we write these premises and conclusion. So, if I take the AND operation of all these premises, that is P1 and P2 and this is nothing but conjunction. P3 conjunction P4 conjunction Pn implies Q. This is always a tautology. That means the last row for this particular expression will give me always a true value. If I get a true value for all these combinations, I can say that it is a tautology. So, if it indicates a tautology, in this case, the argument will be termed as a valid argument. And if it doesn't contain a true value for every possible combination, then we can say that it is not a valid argument or it is an invalid one. So, this is how we express our argument, that is the first premise, then second, then third, then fourth and so on up till n, and at the end we will have therefore conclusion, whatever is there in the conclusion statement. Now, if I want to check that my argument is valid or not, so a valid argument can be described as the argument where if all the premises of this argument are true, then the conclusion also needs to be true. That is, I'll find out that what all are the rows where there is a true value for my premises, and at that place I should have a true value in the conclusion as well. For example, suppose I have a premise if tomorrow is holiday, I will go to mall. Another premise, if I write it as P1, then if tomorrow is a holiday, this is my another premise, P2. And here I have a conclusion, therefore, because I am having a therefore symbol, that means I am having a conclusion Q over there, therefore Q. So now, in order to check that whether this is a valid argument or not, first of all, I'll see and break it into symbols. If tomorrow is a holiday, let me denote this proposition as P. I will go to mall as Q. If tomorrow is holiday, this is again P, and therefore I will go to mall, this is Q. So how can I write this entire combination? This can be written as if P then Q, that means P implies Q. Then the second premise is nothing but P itself, and I have to conclude what? Therefore Q. So actually what I have to show that this one is a valid argument. So in order to show that this one is a valid argument, first of all, I'll draw the truth table for the entire expression. So I have two variables P and Q. So I can have a total input values, total 4 input values, that is both are true. The first one is true, second one is false. First one is false, second one is true, or I can even have both as false. Now next I'll try to find out P implies Q. So as already discussed in the previous lectures, I know that P implies Q means if P is true, then Q should be true. That means if both are true, it will hold a true value. If first is true, second is false, this will hold a false value. Otherwise, if it is false, P is false and Q is true, it will hold a true value. And same, if both are false, it will hold a true value. So this is my truth table if P then Q. So now just see what are the two premises, P implies Q and P. So here I have in this row both my premises as true. The value of P is also true and the value of P implies Q is also true. If I go to the second row, the value of P is true but Q is false. So this is not going to be my critical row. Then coming to the third row, the value of P is false. So this is again not my critical row. And in the last row, if I check, the value of P is again false. So I have to consider only those rows where both my premises are true. So I have only one row here, that is my first row. So here I need to actually check the value of my conclusion. It should also be true. So in this critical row where my P and P implies Q are true, the conclusion is Q. So Q is also true. So what can I say? I can say that this one is a valid argument, since wherever my premises are true, my conclusion also holds. So this is the way how we check the validity of an argument. So for any such type of example or rule where we want to check the validity of an argument, the first step is to draw the truth table. Then we have to find the critical rows. Critical rows basically means the rows in which all the premises are true, and in all the critical rows, then we'll check for the value of the conclusion. In all the critical rows, the conclusion should also be true. If this holds, then we can say that the argument is a valid one, otherwise it is a invalid argument. Now we have something known as quantifiers when we talk about rules of inference. So quantifiers are basically described as collection of statements which are used to describe the truth value of elements in a given predicate. We can divide these quantifiers into two categories. The first one is known as existential quantifier and the other one is known as universal quantifier. Existential quantifier is actually nothing but whenever we want to refer to the objects where we want to use there exists or at least one value is true. So there we use existential quantifier and the symbol for existential quantifier is this one. And the universal quantifier is basically used to represent the words like every, for all, for each. So this is going to be true for all the elements or for every element. So that is why it is known as universal quantifier. So it is denoted by symbol this one. So if we talk about quantifiers, in total we have two basic quantifiers, existential, which is used to refer to some of the objects or there exists or at least one, and whenever we are referring to every, to all, to each, we make use of universal quantifier. So these are the two basic quantifiers which exist. Now applying rules of inference, we can actually construct some more complicated valid arguments with the help of simple arguments which are given to us, which actually work as the building blocks for the new complicated valid arguments. So here we will see that how we can apply these different rules of inference. So we have already some established rules of inference which can directly be applied to different premises in order to conclude any statement. So we will see in the coming slides that what are these rules of inference which can be actually applied directly, and we will also try to establish their validity. So the first rule of inference, which is known as modus ponens, this rule says that if there are two premises, that is P and P implies Q, if I have these two premises, so what I can conclude? I can conclude Q from this. So this rule can directly be applied to a given set of premises, and this is actually known as modus ponens. So if we see what will be the premises in this rule, P implies Q and P. So this is my premise 1, this is my premise 2, and this is my conclusion. So if I want to establish the validity of this rule, what I need to do is I have to see all the rows where my premises are true, my conclusion should be true. So first of all, I'll draw the truth table for this. I have two variables P and Q. So what all values I can have? Either both can be true. The first one can be true and the second one can be false. The first one can be false, second one can be true, or both can be false. So these are all the possible values which can hold for P and Q. Now P implies Q. If I draw the truth values, compute the truth values for these. So if both are true, I'll get a true. If first is true, second is false, I'll get a false. If first is false, second one is true, this is true, and if both are false, then again this is true. So now we'll just see that what are my critical rows. Critical rows means where both the premises are true, and premises are P implies Q and P. So this is the only critical row, because if I see the second one, this is true but this is false. So this cannot be a critical row. This is false, this is true. So this cannot be a critical row. Then this is false, this is true. So again, I have only one critical row in which both the premises are true, P and P implies Q. Now here I'll check the value of the conclusion, that is Q. So the value of the conclusion is also true in this critical row. So I can say that this is a valid argument. So this is a rule which can be applied directly to the premises to check the validity of the given arguments. We'll also see an example. See, if suppose I have P implies Q statement as, if we have a bank account, then we can take the advantage of this new policy. Here my P is, we have a bank account, and my Q is, we can take the advantage of the new policy. And then this is my P again. So I can conclude Q, that is, we can take the advantage of bank policy. So I can say that this is an example which is following the modus ponens rule, because it is of the form where my premises are P implies Q and P, and therefore I can directly say Q. So this is how modus ponens is applied to different arguments. Now coming to the next rule, which is known as Modesto Lens. So what does this rule says? It says that if you have two premises, what are these two premises? P implies Q and not Q. So here we can derive not Q, that is, sorry, not P, that is the conclusion. So what are my premises over here? P implies Q and not Q. These are my premises, P1 and P2. And what I can conclude from here, this is my conclusion not P. So in order to check the validity of what I'll do, I'll again have two variables. I'll draw the truth table. So for two variables, I'll again have the 4 input values. Both can be true. First can be true, second can be false. First can be false, second can be true, or both can be false. Now, finding out P implies Q the same way as we did in the previous example. If both are true, I'll get a true. If first is true, second is false, I'll get a false. If first is false, second is true, I'll again get a true. And if both are false, I'll again have a true. Okay. Now, one of my premises is this one. Now, what is the next premise? It is not Q. So, I'll find the values of not Q. Not Q simply means if the value of Q is true, we'll make it false, and if it is false, we'll make it true. So, first one, it is true, so it becomes false, then second one becomes true, false, and then again true. What we need in my conclusion? Not P. So, we'll also draw the column for not P. Not P simply means whatever is the value of P, will just invert it. So, I'll get a false, false, true, true. So, now let's check the critical rows. That means the rows in which both my premises are true. So, this is not a critical row because the first premise is true, second is false. This is again not a critical row. This is also not a critical row, but this one is a critical row because both my premises are true. So, here I need to check the value of my conclusion. It is also true. So, I can say that it is again a valid rule. So, we can also apply the rule Modesto Lens directly to establish the validity of the arguments. So, we'll just take an example. P implies Q. If we have a bank account, then we can take the advantage of new policy. Here my P is this and this is my Q. We cannot take the advantage of the new policy. This is nothing but not Q. We don't have a bank account. This is my not P. So, making use of these premises, that is P implies Q and not Q, I can directly say that therefore not P will be a valid conclusion by which rule? Modesto Lens. So, this is how Modesto Lens can be applied directly. Now, we have another rule which is known as Hypothetical Salaries. So, in this again, suppose we have two premises of the form P implies Q and Q implies R. So, in this case, we can conclude P implies R from the above two premises. So, this is my conclusion. So, I can just see it with the help of this. P implies Q, this is my premise 1. Q implies R is my premise 2, and this is my conclusion according to the rule Hypothetical Salaries. So, let's just draw the truth table and check that whether it is a valid rule or not. Now, here I have three variables P, Q and R. So, if I have three variables over here, how many inputs I'll be having? I'll be having a total of 8 inputs. Either all of them can be true. First true can be true, third one false. These are the total 8 inputs which are possible. Now, first I'll check the draw the column for my first premise, that is P implies Q. So, P implies Q, both are true, I'll get a true. First false, second true, again I'll get a true. First true, second false, then I'll get a false. Both false, it's again true. False true is true, true false is false, and false false is true. So, I have drawn the column for P implies Q. Now, I'll draw it for Q implies R. Q implies R, true, true will give me a true value, true, false will give me a false value, true, 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 false, true, 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 then false, and then 2 times I'll get a true. So this is what I have got for Q implies R. Now these both are my premises. Now what I need for my conclusion? P implies R. So I'll even draw the column for this. P implies R. So what will it be? Both true, 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 false, 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 true, true. This is true. Then both are true. Then false, true is again true. False, false is true. True, false is false. And then false, false is true. So now first I'll check the critical rows. Critical rows will mean that the for premises I'll see where I have both the premises as true. So one is this one. Then the second one is this one. Then the third one is this one. And then I have a fourth one, that is this one. So I have in total 4 critical rows where both my premises have a true value. So in all these critical rows, I'll check the value of the conclusion, that is this one. So it should be true. So here it is true. In third position, it is again true. Here it is again true. And in the last place, it is again true. So I can say that this is a valid rule and I can apply it directly to establish the validity of the argument. So this one is a valid rule. We'll just see an example. Suppose I have P implies Q. So I have the statement, if my fiancé comes to meet me, I will not go to office. So I can say that the first statement, my fiancé comes to meet me, is P. I will not go to office. This is Q. Then I will not go to office. This is same as Q. I won't require to do office work. So this one is R. This is a new one. So I can conclude that if P, then R. That is, if my fiancé comes to meet me, this was P and this was R. So what we are saying that if I have P implies Q as my premise 1 and Q implies R as my premise 2, so I can conclude P implies R. This is by the rule hypothetical syllogism and this is a valid rule. Now moving to the next rule, that is known as disjunction syllogism. This says that if we have two premises, not P and the other one is P or Q. So now we can directly conclude or derive Q by applying this rule. That is, if I have two premises, not P, this is my premise 1, P or Q, this is my premise 2. So I can conclude Q, this is my conclusion. So let's check the validity of this rule. So here I'll again have only two variables, that is P and Q. So the inputs can be, both can be true. First true, second false. Okay. Now if I talk about not P, it is simply that we can invert the values of P. Wherever it is true, we can write false, and wherever it is false, we can write true. So it will become false, false, true and true. Now P or Q, P or Q, P conjunction Q, the P disjunction Q, this simply means that if any one value out of P and Q is true, then it is going to be true, otherwise it is going to be false. So here P and Q both are true, it is going to be true. Then true false means true, false true means true, and the last one is false false, so it is going to be false since both are false. So now I have two premises, not P, P or Q. Now I need to have the conclusion as Q, which I already have in my truth table. So let's check what are the critical rows where both my premises are true. So I have only one critical row, that is the third one, where both my premises are true. So I need to check the value of the conclusion, that is Q. It should be true in this critical row. So that we can say that it is a valid rule. So the value of Q here is true. So what we can say that it is a valid rule and it can be applied directly to check the validity of the arguments. We'll also see one example. Suppose we are saying that Harry birthday cake is not strawberry flavored. So it is already my not P. The birthday cake is either red velvet flavored or mixed fruit flavor. So this is my P and this is my Q. Therefore, I can conclude Q, that is the birthday cake is mixed fruit flavor. So if I see what I am doing, I have a premise not P, I have a premise P or Q. Therefore, what I am concluding? I am concluding I am concluding Q over here. So this is my disjunctive syllogism, the other rule. Now coming to the next rule, which is known as addition. So what does this rule say? That if you have a single premise which is P, then we can conclude P or Q. We'll just look at it, that if you have P, then you can conclude P or Q. We'll have the same truth table here. The only difference is that I have a single premise which is my P. So although I'll have two variables P and Q, both can be true. P or Q I'll draw. This is going to be true, 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 and this is going to be false. So since my premise is only P, I'm going to check the critical rows where P is true. So this is one critical row and this is the other critical row. So in this, I need to check the value of my conclusion C, that is P or Q. Yes, the first one is true, second one is also true. So what can I say? I can say that this is a valid rule and we can directly apply it to check the validity of arguments. Now we have another rule which is known as conjunction. So what does the conjunction say is, if we have two premises P and the other premise is Q. Now we can derive P and Q with the help of applying conjunction in between. That means my premise 1 is P, premise 2 is Q. If both these are true, I can directly conclude P and Q. So again, we'll draw the truth table. Both can be true. The first can be true, second can be false, second can be false, second one can be true, and both can be false. So if I have this P and Q, this is going to be true, otherwise all are going to be false. So my premises were P and Q. So let's check the critical row. We have only one critical row in which both P and Q are true. Otherwise, one of them is false. So we need to check the value of the conclusion in this critical row. It is true. So this one is a valid rule. So now this is an example simply showing that if the value of my P is Harry is a hard-working employee and the value of Q is Harry is the best employee in the office, then I can conclude that Harry is a hard-working employee and Harry is the best employee in the office. This is by rule addition. Now let's take an example where we'll just directly apply these rules which we have studied and we can establish the validity of the argument. So example, let's take an example. The first premise is, if my fiance comes to meet me, then I'll be happy. The second premise is, if my fiance does not come to meet me, then I will go to office. The third one is, if I go to office, then I will complete my work. The fourth one is, it is asking us that can we conclude, if I'm not happy, then I will complete my work. So how to solve this or establish the validity of this conclusion? That is the last line, making use of the above premises. First of all, what we'll do, we'll just identify the propositions and then we'll use the propositional variables to represent them. Like if I'm talking about the first one, my fiance comes to meet me. So this is my proposition P. I'm denoting it by the symbol P. Then I will be happy. This is my another proposition which I am using symbol Q to represent. Then I will go to office. This is again a different proposition which is being represented by R, and I will complete my work. This is another preposition which is being denoted by the symbol S. So, whenever we get these set of premises, first of all we need to convert them or represent them using prepositional variables like we have done here. Next, after identifying or converting them using these prepositional variables, we'll try to represent the premises and the conclusion in the form of these prepositional variables. So, after putting these prepositional variables, if I try to find out what are my premises are P implies Q, that is if P then Q. The other premise which is already given to me in the question is not P implies R. The third one is R implies S. So, these three are my premises, and the conclusion which I have to validate is not Q implies S. So, I have first written all these things using the prepositional variables and then identified what are my premises and conclusions in the form of prepositional variables. Now, how I'll establish the validity? First, this is my first step. So, I have already P implies Q. This is a premise which is given to me already in the question. Okay. So, first thing what I do, I find the contrapositive of this premise 1. So, I can write it as a contrapositive because they are equivalent. So, the contrapositive for step 1 is not Q implies not P. So, this is my second step where I have done the contrapositive of step 1. Now, the third step, not P implies R. This is already a given premise which is given to me in question. Now, what I do, I know not Q implies not P. I already have established this. Then not P implies R. This is already there. Now, if I apply hypothetical syllogism on both these 2 and 3, what can I say? Not Q implies R. So, I have written not Q implies R as the fourth step. How it is written? By applying hypothetical syllogism on second and third. Okay. Now, the fifth step, I have this premise R implies S. This is already given to me. Now, see, step 4 and step 5, not Q implies R, R implies S. So, we can directly write not Q implies not S. So, from where we are writing this? By applying hypothetical syllogism on step 4 and 5. So, this was my sixth step and this was what I needed to establish, that is not Q implies not Q implies S. So, this is I have directly applied hypothetical syllogism on these two steps, that is 4 and 5. So, finally, this was the conclusion which I wanted to establish and I have been able to establish this conclusion by applying these steps. So, this is how we can apply different rules of inference to the given premises and we can get or check the validity of the given conclusion. Thank you. That was all from my side for this lecture. Thank you.